Can you hear me, Sababu?
Great morning. Yes, give
Okay.
me a second. Got to get out this other window. Okay. Sorry, I was hearing the feedback in the headphones. Okay. So our start time is 11:20, which is about 11:20 now. We do want to say great morning to everyone, and welcome to the integration of computing and English language arts, mathematics, and science. When I look at your name, I want to just like pronounce it like in the French, like Malgoulieu, hello, madame. Like bonjour. But definitely, correct me if I'm wrong. I'm sure the people that have already been here saw you do a excellent job moderating the previous panel. But you can reintroduce yourself for the new people that are here, and you can go ahead and begin. I'm gonna be quiet, be in the background. If you need anything from me, just let me know. I'll come back up or drop something in the chat. Okay.
Okay.
Just to let everyone know, if you would like to enable closed captioning, there is a CC icon underneath the video panels. You can, with a red line through it, you can click on it, and then the red line will disappear, and you should be able to see the closed captioning. And once again, merci beaucoup for everyone who is attending. Thank you very much. Take it away.
Thanks. And thank you everyone for joining this breakout session. So this session is it's sort of geared towards teachers and sort of well, I should take a step back and introduce myself. So I'm a professor at Georgia State University. I'm the director of our computer science endorsement program, and I'll be the director of the SNAP Center for Computer and Teacher Education that was just founded. So basically, our whole goal with the SNAP Center is that we are integrating computing into all of our pre-service teacher programs. But we also are developing a lot of resources that can be used for in-service teachers, especially to help serve our computer science endorsement, which is our computer science endorsement is to add on the field of computer science to another teaching certificate in a different discipline. And so we want to, with that endorsement, recognize teachers' experience and knowledge that they already bring to the teaching realm, and just figure out how that they can then envelop computer science in that knowledge. So the approach that we take is a very integrated approach for introducing computer science. Especially recognizing that many teachers who are going to teach computer science are still going to be teaching in a different area, and that they can use computer science for instruction in their discipline, the other disciplines that they're teaching. So today I wanted to walk through some of the activities that we have developed in our computer science endorsement and with other faculty at Georgia State University that we use in our pre-service programs to introduce our pre-service teachers to computer science. And sort of, I included language arts, a math, and a science activity so that you could see how computer science can be integrated across a range of disciplines. And each of these has sort of they take a different approach to integrating. So that's why I picked the materials that I did pick. So let me figure out how to share. All right. And let me also, let me also put this in chat so you can follow along if you want. So all of these are the activities that I'm going to share have these sort of activity guides that you can adopt or, modify. So I'll be sharing those as we go through. But the integration activity that I wanted to share for English language arts was a chatbot. And so let me pull up the chatbot so you can see. This is a chatbot for Lady Macbeth in Shakespeare. So your students can talk to Lady Macbeth, and she will respond based on these sort of prompts that have the prompts and the responses that are sort of pre-programmed in here. So this activity is designed more as a modifying an existing program than like writing a program from scratch. And so we wanted to do that just because you can see this program is a little bit like it would take a while to develop this from scratch. So most people don't have the time or the inclination to want to develop an entire chatbot from scratch. So instead, we teach this as an integration activity that it starts with Lady Macbeth and it has certain prompts and certain responses that students can then add to, or they can really go in a different direction and change it to a completely different literary character. And so from a English language arts perspective, this helps them sort of inhabit the role of different characters, take a perspective from the character, use different, think about, what is the perspective of the character? How would they respond to certain things? And from that sense, we also sort of at the end, I'll come back to this, but we talk about how this doesn't necessarily have to be for a literary character chatbot. It could be a debate bot. So if you wanted to practice a debate, you could come up with, what would your opponent say in response to certain keywords. It can also be a literary device like dictionary. So if you ask to define alliteration, you can program it to give a definition of alliteration and an example from whatever literary text you're reading. So this can be modified in a lot of ways without really having to spend a lot of time writing the programming elements, but it's still within this programming concept that students are getting exposed to programming and what computer science is. So let me just run this so that you can see what happens. And so it starts with ask me anything. And if I say hello, it'll respond, hello, I'm waiting. So you can see in the activity guide that I shared that the first step of the activity is just understanding what the program does and predicting what the outcomes will be. So if we look through the entire program, it's about 50 lines long. The end of it is this all of the logic that you need for asking the user for input and then returning that into this. It's basically just one function that matches different words that the user inputs to different responses that the chatbot exports. So if you say hello, you can see when it sees the word hello, it will return hello, I'm waiting. And so from there, you can ask, you can ask students to say, so if you say hello and it returns hello, I'm waiting, then if you ask for what is her name, then it should return Lady Macbeth. So you can demonstrate that. And so it responds Lady Macbeth. It probably wouldn't, it would take a little bit longer to actually do this in a classroom, but that's sort of the approach we take to understanding how the program works is we look at the program and try to figure out, try to predict what the program will respond based on different inputs that it has. And then in the activity guide, you can also see there's a couple of special cases that we ask about, particularly because this is a relatively simple implementation of a chatbot. And so if you have two different keywords from two different lines at once, it will return the response for the first keyword and it won't completely ignore the second keyword. So for example, for the next group, you can see that when power, you'll return, I love power, I'll do anything for power. But also you see down here, when it sees the word witches, it'll say, they say that fair is foul and foul is fair, and I agree. So if you ask, what power do the witches have? it will just return the one for power because that's the first one that pops up. I can probably make the screen bigger. Is that better, Co? You can't see like the entire program, but that's all right. There should be a link to the actual program if you have a, so I can take a step back and say that this is made in pencil code. The reason that I really like pencil code is it's a block-based program, so it's really accessible to new programmers, but it's a hybrid block-based code. So you can convert it into text if you want. So you can convert it to blocks or convert it to text. And so if you start to get a little bit of comfort and familiarity with it, but my problem with a lot of block-based code is once you get familiar and comfortable, it can be faster to do things in text, but a lot of block-based languages don't enable that. So I like pencil code because when you get a little bit comfortable with it, you can switch to text. And so like here, instead of trying to figure out in, it is, so it's, I'm looking at Audrey Way's question. So this is, I believe it's CoffeeScript, but then you can also sort of upgrade it to JavaScript. But so here, if you just follow the format of what it had, you can also add additional options. And then you can even click back to text-based and it'll sort of, or click back to block space and it'll sort of blockify it for you if there's no sort of bugs or anything with it. So like figuring out in blocks how to add another option for this when line would be really difficult. But that's the reason I like pencil code is that you can actually, it's a little bit more adaptable than a typical block-based language. Plus, it's just really cool. I find the students really get a kick out of seeing their program in text just because it has sort of that authenticity feel to it that I don't necessarily think is all that important, but they seem to think it's really cool. So, you know, I don't want to discredit that. So that's, we are at 11:35. So that's probably about all the time that I'll spend on the chatbots. Going back to the activity guide, you can sort of see how we go through this as an activity. It's supposed to be, depending on how much you want to modify the actual activity. So if you just want to keep it as a Lady Macbeth chatbot and maybe add some options, it could take like one class period to do the first part of the activity. But if you wanted to do some of those heavier modifications, like changing the literary character, changing it to a completely different sort of chatbot, like the literary definitions and examples that I talked about at the beginning, or if you want to change it to like a debate bot, like that could be a much longer project. And I would recommend that you talk about it or use it as sort of a project in that sense.
Hey, sorry for interrupting. We did have another question in the chat before you move on to the next section. It asked, how does one see the questions that are being asked in the session chat box?
I'm not sure I completely understand. How do you see the questions that are being asked in the chat box? So in the output frame, so pencil code has this blocks menu, and then it has sort of the program workspace menu, and then it has this output menu. So you can see both sides of the conversation in the output menu. So when you hit the button, it'll say, ask me anything. and then your input will be next to that, if that answers the question. And yes, Tom Liam Lynch, I've looked at his materials and they're really cool. I really like his materials. It's sort of a quantifying reading sort of thing. I went through, he has these databases of, plotting plots is what I played with. He has these databases of books, literary books, that you can search for different things, like in the book 1984, you can search for different words and see how they're represented in sort of different acts of the book. And it's like a really cool way to think about what the different themes of the different acts are and how they sort of tie together and that sort of thing. All right. Next, let me just make sure that they're being shared correctly. So the next activity that I'm going to talk about is for math integration. And I say it's math integration, but it's sort of like art as well. So we call this activity drawing with geometry. And it's the premise of the activity is that you can get a computer to repeat things many, 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 many times, way more than you would be able to as a student. And you can also then sort of change and play with really different aspects of whatever it is that you are creating, whatever geometric shape that you're creating, so that you can be really creative and iterative and just try out different stuff. And it doesn't really cost you as the learner much because you're not the one having to execute all the processing. The computer is the one executing all the processing. So it's sort of a fun way to play around with different geometric shapes or different angles. And I see it as a way of getting students sort of experience with different angles, especially if you're talking about geometric principles, like a circle has 360 degrees. And so if I rotate 5 degrees each time I do an action, how many times is it going to take to get to 360 degrees? And it can sort of give students an opportunity to explore those things with like very concrete examples, so that they can get sort of an intuitive sense for it rather than, a very formulaic, like abstract concept of it. So let me pull up this one. I have to find it real quick. Here we go. So I'm going to zoom out a little bit, and then I'm just going to run it so you can see what happens. So you can start with sort of simple shapes and then move on to more complex shapes. And once it stops running, I will sort of walk through what these different things are. And one of the things I like about this activity is that it can be tuned up or tuned down as much as you want. The other thing that I really like about this activity is that it gives students this creative license to create something. And so when we implement this in a classroom with the K through 12 students, what we see is that they figure out new interesting things that maybe the teacher didn't know or maybe they hadn't taught yet. And then especially if you give students a chance to go and look around at each other's designs, the students get really engaged because they're like, oh, how did you do that? I want to do something like that. Can you show me how to do that? And then the student becomes sort of their own expert of whatever feature it is that they found. And, they really get a lot of ownership of their program and, trying to add different pieces that they see other students doing. And it just becomes a really fun, collaborative learning experience. So for those of you familiar with computer science, you might imagine that we're using loops for a lot of these shapes. So this first one, the yellow orangish one. Oh yeah, it says orange. Let me zoom in a little bit. So the orange one is just a simple shape that it's going to go forward and then turn right 75 times. So we can decrease the speed. The activity guide sort of goes through in detail exactly how you do this. So we can slow down the speed. And for 24 repetitions, it went forward and then turned at a 75-degree angle. So this is another one of those cases where, if you're turning at a 75-degree angle, how many iterations exactly would it take to get to a complete shape? And so that's sort of how you can bring it back to the geometry learning objectives. And then for the next one, I'm going to speed it way up because the next one takes a while, but it is drawing a square. So it's got a loop within a loop, which is always sort of fun to watch students wrap their heads around. And so the inner loop is 1 to 4, so repeats 4 times, and it goes forward and it turns right. So it's making a square. And then the outer loop, it's turning right 5 degrees, and then how many times does that need to repeat so that you get all the way around the circle? And so if you're turning right 5, or 360 divided by 5 would be 72. Is that right? I think that's right. I think that's how you do that math. And so basically you can keep going in these loops. Like you can, if you're interested in like doing fractals or something like that, you can keep going within these nested loops, and you can keep making more and more complex shapes, and that makes more and more complex displays. And it's basically just something that you can really pursue this for as long as you want in geometry or even an art class if you wanted to connect it back to math. But it's just sort of a fun way to play around with programming, especially looping. And then the last one, this was one that we created actually in a professional development that we did with teachers because they were working on, or they were about to have their winter break. And so they were creating snowflakes to put in their classroom. And so we made this little program in that PD for creating snowflakes. And we ended up using a function, which I actually think is pretty advanced for computing integration. I know a lot of computing integration activities include functions, but I think it's like not super necessary. But the only reason we created a function was so that we could include a parameter that made different sizes, but the same shape, which would be like the most efficient way of doing it. But you could do, like, if function and parameter are not words that you're aware of, you could totally do this without this, just with regular loops. And it wouldn't like even really be all that different. So that was the last shape that we made, is this snowflake for decorating for winter break. And as you can imagine with snowflakes, you could go in a lot of different directions of how you want that shape to look exactly. All right, so that is one example of a math integration. We do I said this can be sort of scaled up or scaled down depending on the grade of math that you're working with, or exactly how much computing computing integration time you want to spend. But we do actually do a different version of this for elementary students, which is more of just a pattern matching. I can actually, I think I have it pulled up. No, this one's for word problems. I'll find that when the next one is running and show you the pattern matching elementary activity that we have for math. All right, and then I will pause briefly to see if there's any questions about the math before we go on to science. All right, so moving on to our last activity that I wanted to demo is it's for electromagnetic waves, which are introduced in middle school science. At least that's what my science education faculty tell me. And we sort of have different versions of this for high school, since in high school they're more looking at how waves interact with different media, or how light refracts off of different materials. And so we have versions of this for more advanced high school concepts as well. But I wanted to start with, actually, I'm going to start with a basic version. And so this activity is, it's probably our most computing activity that we do, which is to say that we sort of start within this context of waves, and I'll show you how it sort of reinforces scientific concepts of waves, but it's a little bit more geared towards introducing computing concepts as well. So if you look through this activity guide, there's a few different parts to it that sort of stack on each other. So the first part is making an algorithm, which in this case we do in programming. I've tried doing this with sort of like a pseudocode unplugged activity, but I found that students don't, like, if they've never had any exposure to programming, they don't really understand what an algorithm or like an unplugged program would even look like. So often it's sort of just easier to get them started in pencil code because it's block based and they can sort of have a menu of things to select from rather than trying to come up with what they think a program looks like on their own. So we start with pencil code, making an algorithm. And at the very start, we just make one wave. So it just goes up and across and down and across. And none of this is like intelligent at all yet. Like there's no variables. It's just make the I say turtle. This pencil code uses a turtle-based, it's a turtle-based language or a logo-based language, if that means anything to you. If not, that doesn't matter. But you can see this little turtle and it's drawing this line. And then the next part is we add on top of that algorithm to add a loop. And so now instead of it drawing just one time, it draws 3 times, but it's the exact same code, just put inside a loop to repeat 3 times. And then next, we're building the computing concepts through the activity. So next we add variables. So instead of it just drawing for a set number, in this case it's a set number of pixels that it draws for, now we want to say that it's going to move forward for the amplitude and then across for the wavelength. And that way we can change the wavelength and change the amplitude. And this can be used in science as a sort of a tool for how, for getting students to predict how, if you change the wavelength, what's that going to look like? Or if you change the amplitude, what's that going to look like? And so you can use this as sort of a predictive process to reinforce those scientific principles of what wavelength is and what amplitude is and how changing those things would change other aspects of the wave. So we create now a variable for wavelength and amplitude, and then we insert those into any part where the turtle is moving forward. And so this is also another place where you have to really understand how waves are, like what the features of a wave are, because a wavelength is for the entire wave. So if you're going to move for just the top part of the wave, you're only doing half of the wavelength. And so you have to know that in order to make the program sort of work. And then amplitude is only from the baseline, above or below. So the amplitude is at first just 1, but then it's amplitude times 2 to get all the way to the bottom. And then to repeat, go back to baseline, just have 1, and then it repeats the entire thing, and then it repeats the entire thing. All right, so that's adding variables. And then this is just a little addition to add a baseline so that it looks more like a model that a student would have seen in a wave. And now we're going to use we're going to update the variable within the loop of the wave. So we're going to make the wavelength decrease as it iterates. And so at the very bottom, you can see that we've added wavelength equals wavelength minus 3. So the wavelength decreases by 3 every time. When I first made this activity, I forgot to change it to a while loop. So it just decreased by 3 until it started to become a negative number, and then the turtle started drawing backwards. So I figured out that you have to make it a while loop and make it so that it only works while the wavelength is greater than 1. And then the last step is adding conditionals. So if we want to make this like a light wave, then while the wavelength is greater than a certain number, it's going to be red. When it passes that threshold, but it's still greater than this other number, it's going to be orange, and then yellow, and then green, and then blue, and then purple. And so we're adding this sort of if-else conditional to change the color as it goes through so that you get this final result of a wavelength, that the longer wavelengths are red and then the shortest ones are purple, which can again reinforce those scientific principles of visible light. And so I guess I didn't really need to pull up this one because we had the pictures throughout, but you can see the actual program run. And like I said, this is a more computer science-based activity, so it gets more into those programming concepts, but you can also stop at any point along that sort of progression. So you can stop at part C and just add variables if that's what you want to do, or just add loops if that's what you want to do. And let me look through the chat. So for Diane's question, she asks, do we actually integrate these into our pre-service courses so that all future teachers get the experience of doing this? And so yes and no. So we are working on having an integration activity like this for every pre-service program that we have. Currently, we use the examples that I've shown in our middle school science, secondary science, middle school math, high school literature, and then elementary math and science. So we're still working on getting activities. We still need to design some of the activities. They are co-designed between me as sort of the computer science person and the teacher preparation faculty in that field. So, we're really trying to make these authentic activities that teachers find useful to implement in their classroom. But yeah, the idea is that all of our pre-service teachers will have exposure to at least one of these activities when they're graduating so that they can use them in their classes. And what we've found is that if we teach these, so we typically teach them in their methods classes, And if we teach them in our methods classes, some of the students get really excited about it and some of them are very hesitant. But if we can actually get them to implement it in their practicum or their field experiences that they're doing as pre-service teachers, they see how excited the students get about these activities. And then they're really gung-ho about including those in their classes when they graduate. So that's just sort of what we're seeing on our end is half of the teachers are excited about these activities, but then once they see how the students react to them and how interactive the activities are for their students, they get really excited about including them in their class. Let me... So we do need a hackathon to create a bunch more of these. We're actually, so related to this new center that I mentioned, that SNAP is funding, we are looking at getting teachers, some of them from disciplinary backgrounds, some from CSTA in Georgia, and basically getting a bunch of activities for like creating and designing a bunch of activities that people can create. One of the resources that we're working on at Georgia State is also, let me pull up, is sort of aggregating all of the different activities people have developed. And so we have this list of different activities people develop. So you can see, the ones that I've developed with our programs, and then we have Hour of Code activities and CS Connections from Maya Israel's lab at UF, from Diane Franklin's lab at University of Chicago. Lisa Floyd's also a great creator of these things, CS First from Google. So we have this sort of repository of activities that we've been collecting, and we're trying to organize them by topic, as well as what grades they're appropriate for, or what primary discipline they are supporting, and which language they use. And so we are in the process of making a website that is searchable, that teachers can go to and look for a particular topic or a particular grade. And so there isn't access to this spreadsheet, but we are converting it into this website that is searchable. So soon, all of this information should be available in a much more user-friendly way. Otherwise, these are just like my notes for different things. And I am copying that link. All right, let's keep, I know we have about 5 minutes left, so I'm going to keep looking through the chat.
Yeah, we are having some great conversations in the chat. One of the questions related to how could you specifically maybe integrate these ideas in algebra? And we did have one response, but from your perspective, what's like a way that they can integrate these computational thinking ideas in algebra?
Yeah, and so algebra, it sort of depends what level of algebra you're talking about. So one of the ways that I'm interested in integrating into algebra is sort of like I was talking about with the geometry, that just giving students this wealth of concrete examples to pull from so that they develop this intuitive sense of angles or shapes or, sort of geometric principles. I'm interested in the same sort of thing for algebra. So it's a little bit tricky in algebra, talking about variables in computer science and variables in algebra, because they're not exactly the same thing, but they're like functionally kind of are.
Right. And even when you talk about functions, you know, you have your input, you have your function that processes it, and then you have your output.
Yeah. So if you're talking about like, the start of algebra where you're just starting to introduce like variables and how, those can play into equations, I I really like to use computing as a way of just giving students tons and tons and tons of concrete examples of that so that they can sort of do this inductive processing of, drawing the principles out from that and just getting familiar with it and having this intuitive sense of it. And then there's one of the things I've been sort of thinking about, and I apologize for hacking through the explanation of this, but so one of the things, like when you get more advanced in algebra, is that you have to figure out like which formula to apply to solve a problem, like which is the appropriate concept to apply. And so I was thinking of like an end of unit or end of semester project that you could sort of use conditionals of, if you have this sort of information, then you would use this sort of formula. And you could even, automate that formula using functions to sort of, pass the data along that you would get the final result. And so doing an end of project or an end of semester project like that would make students really have to understand like what is this process and really formalize that process. And that's one of the things we talk about in our pre-service programs is we teach programming like teaching a computer. So we'll ask, who thinks that teaching is a good way to learn? And every teacher agrees with that. So we say, well, teaching, like writing a program, is just teaching the computer. If your students can figure out how to tell the program or how to tell the computer how to do a certain process, then they really have to understand it. And if they struggle to figure it out, then they know exactly where it is that you're struggling. And the teacher can even then, because they've sort of externalized it into a problem or into a program, the teacher can come in and say, oh, I see exactly where you're struggling. And so it's really sort of a cool feedback tool for conceptual understanding in different disciplines like algebra.
Okay. And if anyone else has any other questions, you may place them in the chat now. While they're doing that, many of the attendees really want to connect with you. So if you could put your contact information in the chat, I think that would be very helpful to them. And just to remind you, we are about to start lunch in about 3 minutes, 12:05. But please go back and visit the stage. We are having a next raffle. I believe sponsored by Google again. So once this session is over, please revisit the stage for that.
Yeah, and I saw Daryl just mentioned Bootstrap, which has it's like an entire unit on integrated computing and algebra where students actually create a game using algebra. And so it's connected to, I think it's Common Core standards. So if you really want to emphasize computing or like really redesign part of your class to include that Bootstrap, it's got like everything you need for all of the steps of the process. But it would take a little bit of time to sort of get familiar with it and implement it. But I think it's like a 10-week sort of thing that's half and half algebra, half and half computer science.
And then we had two more questions. One, are there any plans to integrate CS into social studies? And then do you have a link to the sheet that had the integrations and subject areas?
So that sheet is just like my notes. It's not in a very user-friendly way, but there is, I'll link the website. So soon, this website is going to be populated with all of those activities so that in a very searchable way. And then so for social studies, when I was making that spreadsheet of all the different activities, I was like, why is there not more social studies in here? Especially like if you, the activities that there were like population statistics and that sort of thing, and visualizing population statistics. And I think part of the issue is that in block-based programming, it's sort of tricky to get like massive amounts of data like you would need for a lot of social studies. If you're looking at things like population statistics. So there are plans to integrate CS into social studies. I think we're going to have to be a little bit creative in how exactly we do that. But I do know, maybe I can pull it up. I do know there is, if you're comfortable with not block space, so if you're comfortable with text-based programming, there is Mark Gusdile at University of Michigan has been working with social studies teachers to create social studies integration activities.
Okay, and I'm sure we can talk about this subject all day. Um, but it's 5 minutes past 12 now. So just thank you very much for sharing. As always, some very pertinent information and cool, you know, some cool things that you can do with computer science. So I hope the teachers out there, you all out there, are excited about the possibilities. So thank you once again. And as stated before, please visit the stage for the next raffle. Thank you. See you later.